before I go on to the next page, because I am going to do the next set, I forgot to mention that of your retest problems, your retest problems would be number 7. So make sure you know how to do basically an inscribed angle, finding that missing arc, and then taking half of it. Okay, and number 8, an exterior angle. I kind of remember this rule. If the angle's outside the circle, it's half the difference of the arcs. So those two are on the retest. Now we're going to go to the next page because to help you finish your corrections. We're going to do 9 through 13 here, and 9 is a reassessment question. Okay, so they want you to find the measure of angle 2. Angle 2 is right here. You want to put an arc there, you can use that. Now to find that, you have to know what type of angle that is. And that pink paper, if you need to look at notes to review, the information on it. I'm going to go ahead and tell you the rule. What you need to know for number 9 is that angle 2 is an interior angle, because the angle or the vertex is inside the circle, but it's not at the center. Okay, the center is T. But angle 2 is an interior angle, and the interior angle equals half the sum of the arcs, the intercepted arcs. And I'm just abbreviating here. So the arcs you have to look at are the arcs that are in between the angle. For angle 2, that would be QR. Since angle 2 is a vertical angle, okay, angle 2 is vertical to angle 4, it would be congruent. So I need that arc as well. I need the arc. I'm going to highlight it just so we can see a little bit better. QR, and then I need the arc that goes with angle 4, and that would be P to S. Right now, I don't have that measure. Okay, it's missing. We got to find it. We're going to find it using what we know about a circle. The sum of a circle is 360. So we're going to add it all up and subtract it from 360. So when we add up the 95 plus 40 plus 105, okay, we add those up, and make sure that's the 40, yeah. And we're going to subtract that for 360 to get the missing angle. So try to do that. See if you can get that angle. If you want to pause, take a minute. I'm going to end up putting it up here. But I want you to see if you can get to your answer first. All right, you should have, I'm going to erase this part just so we can label it. We should have that the missing angle is 120. Oh, sorry. Is 120. Okay. If you're not sure how that happened, well, you need to make sure you check your addition. So you added the arcs, and then you make sure you subtract from 360. So once I know that arc, then I can get to my angle 2, because it's the sum of my yellow arcs. Those are the arcs that are inscribed or intercepted with that angle. And so I'm going to write it over here. Angle 2 would equal half of the 120 plus the 140. I mean, plus the 40, sorry, because that was QR. All right, so I'm taking 1/2. Order of operations tells me, PEMDAS tells me to do what's in the parentheses first. And that would give me 160. Yep. And then half of 160, or basically you're saying 160 divided by 2 is 80. So our answer here was C. Okay, it's 80. So on your reassessment, we're just going to change the number, see if you remember how to do that rule. And then make sure that you add them when it's inside. When it's outside, you subtract. So we're adding when it's inside, and we're going to take half our answer. All right, so number 9. This was, oh, and I forgot to put the answer. Sorry. 240. You didn't do that. On number 9, the circumscribed a triangle about the circle Q. If the perimeter of the triangle, so that's our distance around, that's the key information. Perimeter of triangle is 30. MR is 4, so I'm going to label that's 4. SN is 6. SN is 6. They want us to find PT. Okay, want us to find PT. All right, so we have a theorem that says that, one, you need to be able to know what type of segment, and I'm just going to draw it over here. So if I have a circle, and I have a segment or a line, okay, that comes from outside the circle and only touches the circle at one spot, that's called a tangent. if those tangents come from the same spot, same point, so they both come from, let's say, A, kind of making a cone head. I'm hoping you see that. Then the cone head theorem or the tangent theorem states that those two tangents are congruent. So what you needed to realize is that MR and MS are the same. So if I give you one, you should write and label the other. So who else is the same as NS? Exactly, NT. That's 6 right there. And then I'm trying to find PT, but PT is going to equal PR. So I'm going to go ahead and put an X there too. Now I'm going to use what they gave me, the perimeter. It says that the perimeter is equal to 30. Perimeter is your distance all around. So that means I'm adding up all my segments, all my parts. So I have 4 plus 4 plus 6 plus 6 plus X. Oops, sorry. Plus X and plus X. I know that's messy. So really, when I simplify this, this becomes 20 plus 2X equals to 30. Well, if I subtract 20 from both sides, we get 10. And I'm going to move over here. Equals 2X. So X equals exactly 5. So that takes care of number 10. On number 11, I was hoping that y'all could tell that this would make a right angle because this segment, E to R, excuse me, that is a tangent. And whenever a tangent, I'm just going to abbreviate, when that point of tangent touches the radius, it's always perpendicular. So to find my radius, I'm just going to go back to since I have a right triangle here, a squared plus b squared equals c squared. So I can say A could be my radius, B can be my 15, so 50 squared, and C, their hypotenuse is always opposite the right angle, 17 squared. So R squared plus 225 equals 17 squared is 289, and then we subtract to get the R by itself. So minus the 225, oops, sorry. So R squared equals 64, and then we take the square root, don't forget that. So R equals 8, okay? So that was how we worked that. Pythagorean theorem, you're going to see the remaining of the semester and on your exam, so semester exam. On number 12, we had to use a circle, what we know about a circle being 360, and you had to understand that this angle here, A, I'm going to just highlight it. I'll do it with, let me do it right. Let me highlight it. This angle, A to B to C, that is an inscribed angle. Because the vertex is on the circle. And whenever you have an inscribed angle, it's equal half the arc. Okay, half is intercepted arc. So I know that ADB, so I'm just going to follow A to D to B. That whole curve right there is 220 degrees. So I need to find my missing arc AB. Because if I find that missing arc, I can get to my angle. And I can get to that missing arc by basically just taking my 360 minus 220. And I get 140 that remains. So that's 140. So to get to my arc, get to my angle, I take half of the 140. So our answer was 70. Okay. So that takes care of all the circles. Now we're going to get into area. And I was kind of hoping that we could read and plug in our formula for our formula chart. Excuse me, that you got to use to find your area. So this is area of a parallelogram. On your formula chart, it says A equals BH. What does B represent? The base of the parallelogram. That would be the 8. H, the height. That would be the 6. So all I needed to see, or some of you did it mentally, 8 times 6, which gave me 48 meters squared. Okay? All right, so next video will take care of the remaining area problems. And of those problems, 16 and 17 will be on your reassessment. Thanks.